Section 5.8, the Pythagorean Theorem. In this video, we will see the origin of the Pythagorean Theorem, how the Pythagorean Theorem is defined, and how to use the Pythagorean Theorem to find the unknown side of a right triangle. Pythagoras was a Greek mathematician and philosopher, born on the island of Samos. He founded a number of schools, one in particular in a town in southern Italy called Croton, whose members eventually became known as the Pythagoreans. The inner circle at the school, Mathematico, lived at the school, rid themselves of all personal possessions, were vegetarians, and observed a strict vow of silence. They studied mathematics, philosophy, and music, and held the belief that numbers constitute the true nature of things, giving numbers a mystical or even spiritual quality. Today, nothing is known of Pythagoras' writings, perhaps due to the secrecy and silence of the Pythagorean Society. However, one of the most famous theorems in all of the mathematics does bear his name, the Pythagorean Theorem. Prior to revealing the contents of the Pythagorean Theorem, we pause to provide the definition of a right triangle and its constituent parts. A triangle with one right angle, 90 degrees, is called a right triangle. In the figure below, the right angle is marked with a little square. The side of the triangle that is directly opposite the right angle is called the hypotenuse. The sides of the triangle that include the right angle are called the legs of the right triangle. Now we can state one of the most ancient theorems of mathematics, the Pythagorean Theorem. The Pythagorean Theorem. Let C represent the length of the hypotenuse of a right triangle, and let A and B represent the lengths of its legs, as pictured in the image that follows. The relationship involving the legs and hypotenuse of the right triangle, given by a squared plus b squared equals c squared, is called the Pythagorean Theorem. Here are two important observations regarding the hypotenuse of the right triangle. 1. The hypotenuse is the longest side of the triangle and lies directly opposite the right angle. And 2. In the Pythagorean equation, a squared plus b squared equals c squared, the hypotenuse lies by itself on one side of the equation. The Pythagorean Theorem can only be applied to right triangles. Let's look at a simple application of the Pythagorean Theorem. Example 1. The legs of a right triangle measure 3 and 4 meters, respectively. Find the length of the hypotenuse. Solution. Let's follow the requirements for word problem solutions. 1. Set up a variable dictionary. Let C represent the length of the hypotenuse, as pictured in the following sketch. 2. Set up an equation. The Pythagorean Theorem says that a squared plus b squared equals c squared. In this example, the legs are known. Substitute 4 for a and 3 for b. 3 for a and 4 for b works equally well into the Pythagorean equation. So we get 4 squared plus 3 squared equals c squared. 3. Solve the equation. Simplifying the exponents first. 4 squared on the left equals 16 and 3 squared equals 9. Then 16 plus 9 equals 25. So we have 25 equals c squared. If we take the non-negative square root of both sides of the equation, we're left with 5 equals c. Technically, there are two answers to c squared equals 25, i.e. c equals negative 5 or c equals 5. However, c represents the hypotenuse of the right triangle and must be non-negative, hence we must choose c equals positive 5. 4. Answer the question. The hypotenuse has length 5 meters. 5. Look back. Do the numbers satisfy the Pythagorean Theorem? The sum of the squares of the legs should equal the square of the hypotenuse. Let's check. 4 squared plus 3 squared equals 16 plus 9 equals 25, and on the right, 5 squared equals 25. All is well. Example 2. Given the following right triangle, find the length of the missing side. Solution. Note that the hypotenuse across from the right angle has length 13. This quantity should lie on one side of the Pythagorean equation all by itself. The sum of the squares of the legs go on the other side, hence 5 squared plus x squared equals 13 squared. Solve the equation for x. To get x squared by itself, we'll subtract 25 from both sides, so we have 25 plus x squared minus 25 on the left, which is x squared, and on the right, 169 minus 25 is 144. So we have x squared equals 144. We can simplify both sides by taking the non-negative square root of both sides. The non-negative square root of x squared would be x, and the non-negative square root of 144 is 12. Perfect squares are nice, but not required. Example 3. Given the following right triangle, find the exact length of the missing side. Solution. Note that the hypotenuse across from the right angle has length 12. This quantity should lie on one side of the Pythagorean equation, all by itself. The sum of the squares of the legs go on the other side, hence x squared plus 7 squared equals 12 squared. Solve the equation for x. Subtract 49 from both sides. On the left, x squared plus 49 minus 49 is x squared, and on the right, 144 minus 49 is 95. Then if we take the non-negative square root of both sides of the equation, we're left with x equals the square root of 95. Hence, the exact length of the missing side is square root of 95. Important observation. Any attempt to use your calculator to approximate square root of 95 in example 3 would be an error, as the instructions ask for an exact answer. Sometimes an approximate answer is desired, particularly in applications. Example 4, Guinea wanted to create a vegetable garden in the corner of her yard in the shape of a right triangle. She cuts 2 boards of length 8 feet, which will form the legs of her garden. Find the length of board she should cut to form the hypotenuse of her garden, correct to the nearest tenth of a foot. Solution. We will follow the requirements for word problem solution. Set up a variable dictionary. We begin with a labeled sketch. Let x represent the length of the unknown hypotenuse. 2. Set up an equation. The hypotenuse is isolated on one side of the Pythagorean Theorem. Equation. X squared equals 8 squared plus 8 squared. 3. Solve the equation. First, simplify the exponents. 8 squared equals 64. So we have 64 plus 64. Then 64 plus 64 is 128. X squared equals 128. If we take the non-negative square root of both sides, we get x equals square root of 128. 4. Answer the question. The exact length of the hypotenuse is square root of 128 feet, but we are asked to find the hypotenuse of the nearest tenth of a foot. Using a calculator, we find an approximation for square root of 128, which is 11.313708499. To round to the nearest tenth, first identify the rounding and test digits. The test digit is less than 5, so we leave the rounding digit alone and truncate, therefore correct to the nearest tenth of a foot. The length of the hypotenuse is approximately 11.3 feet. 5. Look back. The sum of the squares of the legs is 8 squared plus 8 squared equals 64 plus 64 equals 128. The square of the hypotenuse is 11.3 squared equals 127.69. These are almost the same. The discrepancy due to the fact that we rounded to find an approximation for the hypotenuse.